All right, so today, moving into kind of the meat and potatoes of this particular unit. All right, yesterday we did a lot of review with graphing, coordinate planes, and everything else. So really the rest of this unit is going to be centered around the ideas of relations and functions. All right, and so as I was kind of alluding to yesterday, this is all going to be brand new. All right. We're going to break section 8.1 into a couple different days because I really want us to get good at determining what is a relation and what is a function. And I will tell you that there's going to be a couple different ways to explain it. We're going to focus on one way today, we're going to focus on another way tomorrow, and then on what day would that be? Thursday, we're going to bring everything together and expect you to differentiate when to use one and when to use the other and everything else moving forward from there. Okay? So, we're going to begin today. We got to get through all the vocabulary before we can take a look at any of our examples, okay? Because every single one of our examples today deals with what is the domain, what is the range, and determine whether a relation is a function. So we're going to get through the first four definitions. We're going to leave the vertical line test until tomorrow. That's the second method that we're going to use to determine what is and is not a function, okay? So first of all, definition of a relation. Here's what I'm going to tell you. In unit number 7A, and actually also in unit 7B, and really from here on out, everything is always going to be a relation. Okay? Our job is to determine, is that relation also a function? And some people are like, I don't know what you mean by that. Okay, so I'm going to give you this example. I know you have not taken geometry yet, but you all know enough about this. Okay? A rectangle. What can you tell me about a rectangle? There's four sides and what? More than just four sides. Two of them are the same length. And there's also four right angles. Would everyone agree with that? Okay, so if I said draw the picture of a rectangle, I think most people would know that I've got a four-sided figure that's got four right angles. Whether or not you actually know what that means, you've at least seen the picture. These two side lengths are the same, and these two side lengths are the same. Okay? So now I've got a question for you. If I give you a square that has four right angles and four congruent sides, okay? If we think about what makes a rectangle, our squares considered rectangles. Even though we have different names for them, they fit the same definition there. Yeah. Yes. So here's what we can tell you. All squares are rectangles, but not all rectangles are squares. Does that make sense? Okay, same idea here. Everything we're looking at is a relation. Our job is to determine, is that relation also a function? Okay, so all functions are relations, not all relations are functions. Same idea is what we're talking about with the square and the rectangle idea right here. Okay? So, what is a relation? This is a pairing of numbers Yes. Yep. A pairing of numbers in one set. Oh, sorry, hold on, not 5B. No? That's my old one. Alright, so a pairing of numbers in one set, okay? This is what we call the domain. With numbers in another set. Called the range. All right, that is what a relation is. And a relation, ladies and gentlemen, literally can be anything you want to talk about. Like, if I have two sets of data, and I'm talking about one of those sets being the domain, which we call the input idea, Okay, and one of them being the range, which we call the output idea. And I start putting those together, that creates a relation. Okay, I'm going to give you some examples that we're going to look at that kind of fit the math examples, and I'm also going to kind of talk about some examples that we may see in the real world. Okay, of what is a relation. Okay, so here's the first example that I'm going to give you. I could give you a list of ordered pairs. This would be an example of a relation. And I realize there's not a whole lot of writing room to jot this down, but I at least want you to kind of be exposed to what I'm talking about here. So if I gave you a list of ordered pairs, we'd have an x coordinate listed with the y coordinate. We did this yesterday. All right, here's an example of a relation. All right, you've got number in one set, which we call the x coordinate, paired with a number in another set, which is the y coordinate. Okay, and really what we're going to find out over this entire unit is we can show relations really in three different ways. Okay, we're going to show relations just by giving you a list of ordered pairs. That's one of the examples that we're going to talk about today. Okay, I also can give you a relation using something called a t-table, where literally we list on one side the x values and we list on one side the y values. So if this is a relation right here, I could also show that relation by using a t-table just like this, where 5 and 4 are paired together, -3, -1 are paired together, 4 and 3 are paired together, and 6 and 0 are paired together. Okay, same idea. Or what we did yesterday was we took a bunch of ordered pairs and we created a graph. So this is just going to be a real rough sketch, but if I graph the ordered pair 5, 4 here, and I graph the ordered pair -3, -1 here, the ordered pair 4, 3 right here, and the ordered pair of 6, 0 right here, this is another way to show a relation. You can do it with a list of ordered pairs, you can do it with a set of, or a table with values, or you can actually do it on a graph. We're going to focus on this one tomorrow. Today, we're going to focus on these two. Okay? But here's another example, because sometimes people are like, this is just like some random numbers. Think about this. What if we were to go through and create a list of everyone's height in class and their shoe size? Okay? Like we were collecting data on them. And we all realize how that's related to one another, right? The taller you are, the bigger your shoe wide. Anybody know the proportions that work in your body that way? No? You guys never heard that before? Okay. Your approximate height is fingertip to fingertip if you do this right here. Did you guys know that? Okay, your wingspan and your height are approximately the same matter. Here's the other one that most people don't realize. Your shoe size is wrist to elbow. So, now everybody's doing this. The bigger your foot, the bigger your wrist to elbow, isn't it? And the bigger your wrist to your elbow, the taller your wingspan is, which means the taller you are. It's all tied together. You don't see 7-foot people walking around with size 5 feet. Okay, now it's a little different for students that are in high school because your body hasn't fully developed, but like if you look at the people that are, when I look at middle school students and I look at their size 14 feet, I'm like, holy buckets, those kids are going to be tall. Because their feet are really big, and at some point their arms are going to grow that long, and at some point their body's going to grow that tall. Okay, one of my son's classmates has size 15 feet. Okay, doesn't shock me. He's in 6th grade, but his dad's about 6'7". It's probably going to happen that kid's probably going to be 6'6", 6'8", somewhere in there. And I can tell that when I look at his feet. Like he stumbles right now as he walks. That's why a lot of tall kids are uncoordinated when they're little, because their feet are so much bigger than the rest of their body. But if I went through and said, what is everyone's height? And I put that in one column, and on the next column I put everybody's shoe size, there would be a correlation, but there's also that's a relation, isn't it? My height is my input and my shoe size is my output. Okay, that's really all it is. So these numbers today are going to be made up numbers, but at some point there's going to be a relationship between the x coordinate and the y coordinate. Okay, and by the end of this unit, we're going to see that we're going to relate those by equations. Okay, but right now we're just kind of looking, I'm just throwing out random numbers. That's all that so when people are like, well, how did you get 4 when you plugged in 5? I really just made up numbers. Okay, we're just making stuff up today. But at some point, all relations, the input and the output are going to be related to one another. All right, now I got 3 more definitions here. Okay, the next one is my domain. All right, now here's the rule, or sorry, this is all what the definition is. So this is the set of all possible inputs for a relation. The set of all possible inputs for a relation. Now, I'm going to add a little bit to this definition because, again, we're going to look a lot at ordered pairs, tables, and graphs. So often when we are talking about the domain, we are often talking about the x-coordinate. So if it's listed as an ordered pair, we're talking about the x-coordinate for that. I'd like you to add that to that last part of the definition. Okay? Our range is going to be the set of all possible outputs of a relation. Okay? And this, if we've got a set of ordered pairs, a table, or a graph, is often what we think about as the y-coordinate. You will often also hear me talk about this idea of input and output. Probably more as we get into stuff next week, but my input is my domain. It's what I often plug in for my values, the x values, and the output is my range. It's the y values. Okay, and again, this is all tying together. I'm going to use a lot of different vocabulary over the next couple of days. My goal is by the end of the unit that we can see how this all matches in together. I don't want to just focus on one idea today and then one idea tomorrow, and we're going to continue to use this vocabulary ideas all together. Okay? Now, well, we'll save that. I don't want to include it as part of the definition. We're going to talk about how we list domain and range, but we'll do that when we actually get to the example of it. Okay? All right. Last definition for the day today. What is a function? Okay, first of all, as I talked about using the square and rectangle idea, all functions are relations. Everything's a relation. Our job is to determine if a relation is also a function. That's the big idea. Okay? So here's what a function is. This is a relation in which each input, okay, which I'm going to talk about here as our domain, in which each input has exactly one output, which we talk about when we discuss our range. A relation in which each input has exactly one output. I'm going to be honest, this is probably the first vocabulary word that if you know what you're doing, you're going to be able to repeat this almost verbatim by the end of this week. Okay? All the other pieces are key. This definition is something that I'm going to expect you to have memorized. Because when I ask, is this a relation of function, it's going to be answered with a yes or no question, or a yes or no statement. But then the follow-up is going to be explain why or why not. And if my follow-up is this is a function, I am going to use this. Each input has exactly one output. Literally almost every single time. And if I'm going to tell you that it's not a function, it's because not each input had exactly one output. Now, what does the word exactly mean? What's that? Spot on. Okay, so if I say that each input has exactly one output, can my input have two outputs? No. Can my input have zero outputs? It must have exactly one. The only way that a relation is a function is if each input has exactly one. No more, no less. All right. Questions or anything so far on our vocabulary terms? All right. So let's actually move into our examples today. Again, we're going to save vertical line test for tomorrow. It is a little bit lengthier definition, so that's why we've got so many lines there. But I want to work through example A. Okay, and then let you guys work through example B. But there's a couple things more than just definitions that we need to know for all of this right here. So, the table shows the height of a tree at different ages. Identify the domain and range, then determine if the relation is a function and explain why or why not. Okay, I'm going to tell you right now, you've got to be able to do all of this for your assessment on Friday. All right, so I like to create my t-tables, and I call them t-tables because it looks like a big T. Okay, I like to create my t-tables vertically. Your textbook likes to create them horizontally, so I'm trying to do them both so you can see that they really mean the same thing for us here. All right, so when your table is listed vertically, horizontally, like this one here, this top value is going to represent your input or your X values, and the bottom one is going to represent your output or your Y values. So when I go to list my domain says it's the list of all possible what? Of all possible inputs. So what did we say our input was? The age or the height? It's the age. Okay. So we need to list every number that's in the age group on that list. But here's the thing. This is the big thing. Okay? And I'll write this right here. Domain and range must, not can, but must be listed from least to greatest and no repeating values. Now, when I say no repeating values, that means that I cannot list the same number twice in the domain. I could list it once in the domain and once in the range because those are two separate groups. Okay, but I do not ever repeat a number in my domain and I do not ever repeat a number in my range. So those are two things to remember. I'm going to continue to try to quiz you guys on this. What's the rule for when listing domain and range? In order, least to greatest, no repeating values. That's what we need to remember, okay? So, I specifically created this table so it's not in chronological order. I didn't want us to just grab the table and list them in order because the table was in order. I want you to make sure that you're always checking that. So, when it comes to listing our domain, we're listing all the values that represent our inputs, okay, which we said is the age of the tree. So what is the smallest age of the tree that we have in our table? 5. Okay, after 5, the next smallest age is 10, followed by 15, followed by 20, followed by 25. Now, it just so happens that none of these values repeated, so I was able to list them all and that was it. Okay, but if 25 showed up twice, then I would still only list it once. Okay? Now, when it comes to my range, we list the same order, or same rules. Least to greatest, no repeating values. So if my age in years was my domain, my height in feet must be my range. What's the smallest height of that tree? 13, followed by what? Followed by 25, then 34, followed by 43, followed by 52. Okay, and again, it just so happens that this range did not have any repeating values. So I listed them all, but they must be listed in order from least to greatest. All right, that's the first part, and I'm going to get rid of this so you guys keep it on there so you know it, but I'm going to get rid of this because we've already classified domain and range. Now our job is to do the second part. Determine whether or not this is a function and explain why right now. Two ways to do this. Today we're going to concentrate on something called a mapping diagram. Okay? And a mapping diagram literally just shows me how one set of values, which is my domain, is listed or related to the other set of values, which is my range. So when I go to list my domain and range here, okay, this value right here is going to be my domain. This value right over here is going to be my range. When I go to create my mapping diagram, I'm going to follow the same rules that I did right here. Least to greatest, no repeating values. So I have 5, 10, 15, 20, and 25. Okay, and over here, we have 13, 25, 34, 43, and 52. Now, what you need to do to complete your mapping diagram is you need to group together the numbers that are in your domain with the numbers that go to the range. Here's what I mean by that. When you look at your table, what was the height of the tree at 5 years? 13. So I'm going to draw a line from 5 to 13. Okay, the next one shows that at an age of 25, it was 52 feet tall. I'm going to draw a line there. Okay, my third value shows me that at an age of 10 years, it was 25 feet tall. I'm going to draw a line between those two. My fourth one's going to show me that at an age of 20, it had a height of 43. And draw a line there. And my last one shows me that at an age of 15, it had a height of 34, which is going to show me right there. Now, I'll be honest, this is kind of the most plain mapping diagram you have. Sometimes the number lines will cross one another. I really don't care. Okay? Sometimes people are like, well, does it always have to look like this? No, I might have this. That's fine. Okay, I draw it however it needs to be drawn. But for this particular problem right now, everything is lined up right across from one another. So it looks like this, okay, and then again like this. Now, what did we say made a relation a function? What has to happen for it to be a function? Each input has exactly one output. So here's my question. This input has how many outputs? One. Okay, that's good. This input has how many outputs? They all have one. So here's my question. Is this a function? Does each input have exactly one output? Yes. So as a result, we can say that this is a function. Now, that's the first part of it. The second part, and this is the big thing, you got to be able to explain why. And as I said, we're going to go right back to our definition. This is a function. Each input has exactly one output. That's what I'm going to write for that one. Each input has exactly one output. I am picky in how you describe what is and is not a function. And I'll be honest, if I'm using a mapping diagram and it's a function, then pretty much this is what I write every time. Now, you guys don't need to copy this down, but I at least want to show you this a little bit, because again, this is kind of a blah mapping diagram. Let's say that just for a minute, I have all my same values here, okay? But they were matched up a little bit differently. So I had 5, 10, 15, 20, and 25. And over here we said we started with 13 to 25, to 34, to 43, to 52, okay? Let's say that the table was different. Let's just throw that out there for a minute. And I started to get a mapping diagram that looked like this. Oops. Okay. Is that a function?
Yeah.
Yeah.
Yes, because each input has one output.
Yes, it is. Each input has exactly one output. Now, the lines are crossing one another, but that doesn't matter. You come back to this picture, 5 has exactly one output. 10 has exactly one output. 15 has exactly one output. 20 has exactly one output. 25 has exactly one output. This would still be a function, even if the lines cross. And that's always a big thing. Like, some students kind of get caught up on that. No, they need to go straight. No, they don't. It goes back, does each input have exactly one output? Okay, now, let me give you another hypothetical here. Is that a function? Why not?
There's more than one.
There's
Going to 2.
There you go. This is not a function. You're going to be specific in why. It's not a function because 10 has 2 outputs. 10 goes to both 13 and 10 goes to 25. This is not a function. Does that make sense?
Does it matter that 25 has 2 things?
No.
It's just the output.
It's just the inputs that we're looking at. Okay, again, I'm going to keep going through these because there's a lot of different scenarios that I want to consider. Let's say I completely change my domain and range. And so now here's my domain, 1, 3, and 5, and my out range is 0.
Yeah.
Is that a function?
Yeah. Because each input has exactly one output.
Does each input have exactly one output?
Yeah.
So is it a function?
Yeah.
Yep. Does it matter that they all go to the same one? No. All we're concerned about, does each input have exactly one output? Yes, it does. This is a function. Is that a function? No. Because the input of 1 has 2 outputs. This is not a function. So again, we're not worried about lines crossing, lines not crossing. This all comes back to, is this a function because each input has exactly one output? All right, so on the back, I literally just made up a table. It doesn't have like a height, weight, whatever to it. So here's what I want you to do. Create your domain and range. I shouldn't say create, list your domain and range. Remember the rules for that. In order, least to greatest, no repeating values. Create your mapping diagram. And then before you do a ton of writing, just ask yourself, is this going to be a function or not? Okay, so domain, range, mapping diagram. You don't need to explain why not yet. Okay? But at least ask yourself what you think it would be.
I'm gonna remind you guys, when you list a domain and range, see these little squiggly bracket things? You're gonna wanna have that around your list of things. That's actually a symbol that means you're listing a series of something or a list of something.
All right, so let's start with this. So let me remind us, what's our rule for domain when we list it?
You only list number one.
Least to greatest, I heard both of them. Delaney said one, Jacinta said another. Jacinta said we're going to list it in order from least to greatest. Delaney said
You can only list number one.
you can only list the number once. All right, so what is my smallest value in my domain?
2.
2, followed by 3, followed by 5, followed by 6, followed by, that's it. Now again, you might say, well, but hold on, Mr. Tompkins, there's 5 values in your table. Yep, there are. But 6 shows up twice, and I don't repeat it. And it's key that you don't repeat it. Because if you repeat it, and you repeat it in your mapping diagram, it's not going to tell you what it needs to tell you. Okay? What is my range in this problem? 0, then 1, then 4, and that's it. Just those 3. Now, when I go to create my mapping diagram, I'm just going to copy this domain and range that I have. Again, some people start listing all of these over again. And again, when you start repeating a number in your domain or in your range, the mapping diagram has lost its effectiveness. It doesn't work anymore. Okay? So we're going to go with 2, 3, 5, and 6 here, and 0, 1, and 4. And I don't want to miss anything, so I'm just going to work my way from left to right and draw lines as I show. So this first ordered pair, 2, 0, says I'm going to draw a line from 2 to 0. My second ordered pair says I need to draw a line from 6 to 4. My third ordered pair says I need to draw a line from 5 to 1. My next ordered pair says I'm going to draw a line from 3 to 4. Okay, I'm going to ask right now, if I were to stop, would this be a function?
Yes.
Yes, it would. Because each input has exactly one output. Okay? But I still have one more to list. I need to draw a line from 6 to 0. Is this a function? No. And you're going to need to be specific. So here's what I'm looking for. This is not a function. Now, here's what I will tell you. It's still a relation, though. Because everything's a relation. Now, when it's not a function, I need you to be specific and tell me why. What number in the domain is causing this to not be a function, Caitlin? Perfect. So this is not a function. The input of 6 has 2 outputs. And the fact that it's got 2 outputs means it doesn't match the word exactly. It's got to have exactly 1 output. Okay? This one has 2 of them. Again, for us to show a complete understanding, I need this number to appear in part of my description. If you were to just say this is not a function because it has too many outputs, what has too many outputs? Okay? Be specific and tell me the one that it is, because here's what sometimes happens. And this is why I'm always picky with my explanation. Sometimes students will say this is not not a function, but they think this is the problem. The fact that 2 of them are going to 0 is not the problem. The fact that 2 of them are coming from 6, that's what makes it the problem. That's what makes it so it's not a function anymore. Okay? All right, questions on this? Perfect. Then your assignment for tonight is going to be page 403. Numbers 1 through 17. Please make sure that you read the directions and you know what the question's asking you to do. Because these can look a lot alike. Okay? You need to make sure that if it's asking for the domain and range that you're giving that. Okay? You need to make sure that if it's asking for is this a function or not, you're doing that as well. And again, the only way that we have right now to determine what is a function, I would expect to see a mapping diagram being used.